Welcome, student, to section 10.3, where we will do business application or optimization problems in business. So in this question, example number 1, we have a company manufacturer that sells Q phones per week. The weekly demand function, which is the price, is given by this formula. Find the selling price that maximize the revenue. Now, whenever we see the word maximize the revenue, we need to write the revenue function, and then we need to find the maximum of the revenue function. So first question, we need to maximize the revenue. What is the revenue function? Revenue function is always given by, of course, here I'm using Q for the quantity, always the number of units times the price. So it will be Q times 500 minus 0.5 Q, and this is just 500 Q minus 0.5 Q squared. Next, we need to find the local maximum. That's what does it mean for finding the maximizing of the revenue, finding the local maximum of R of X. Now, do you remember how we find the local maximum? It should be yes, because first step, we need to find the critical number where the derivative is equal to 0. Second, we will apply the second derivative test. So just let me write them as a step. We find the critical numbers. And then we will apply the second derivative test to see which of these numbers is maximum, and that number I will grab and that number I will take. So we need to find the derivative. What is the derivative? The derivative will be 500 minus Q. And we will need to write this one equal to 0. So my Q will be just 500. Now we don't know if this is maximum or minimum. I don't know yet. So what we will do, we will apply the second derivative test. Now, what is the second derivative test? The second derivative test is we need to find, sorry, this is not F, should be R. Second derivative test, it means R double prime of X, and that would be just -1. Next, we need to substitute 500 inside the second derivative. Now, if we put 500 here, regardless of whatever X you write here, the answer is always -1, and -1 is less than 0. Hence, by the second derivative, we know that, hence R of X has a local maximum at Q equal 500 units. Okay, now the question was not how many Q to get the maximum. If you look at the question, it says find the selling price. I need the price, I need P, not just Q. So I know that Q is 500. What is P? So let's find the price. So we have the local maximum at 500 units with the price, and that's what I'm looking for, P equal 500 minus 0.5 times 500. So the answer will be in dollars, $250. dollars will give me the maximum. Finally, you just need to find the maximum revenue. Remember, this will be the maximum revenue you are looking for. Even if the question is not being asked directly, I'll just find it up here. So the maximum revenue, you will go back to the revenue function and you just need to substitute 500 everywhere, which will equal to, if we just substitute it using the calculator, 125 dollars. That's the maximum revenue you can get out of this function. Why this example is very important for business application? It will tell the manager of the company that the maximum revenue, no matter what you do, no matter how many items we sell, the maximum we can get is $125,000. That's the maximum we can get. So the company, in order to maximize its revenue, it has to produce only 500 and exactly 500 phones. And that's the first question. Let's go to the second question. Again, a company manufacturer sells Q products. The demand function is given by, the price is given by this formula here. Find the selling price that maximizes the revenue. Now, this question is very much similar to the previous one. So we will solve it by the same way. So again, we need to maximize the revenue. So you need to find the revenue function. Now, what is the revenue function? It is R of X equal Q times P. How much Q? Q is a Q times P, which is 100E negative 0.01 Q. So all in all, this will be 100 Q E negative 0.01 Q. Now, this is the R of X. Our goal is to find the local maximum of R of X. What is the local maximum of R of X? Now remember, how do we find the local maximum of a function? We need to find the critical numbers and then we need to check the second derivative test. So let's go ahead and find the critical number. Just for clarity, let me just write the function again here so that we will take the derivative in a minute. So first step, we find the critical numbers. Now, what is the critical numbers we have here? We find the derivative. Now, in order to find the derivative, you need to use the product rule. Why product rule? Because I have Q, I have E. So you will have 100, keep it out. First of all, derivative of first times the second plus first times derivative of the second. Now, what's the derivative of first? Derivative of a Q is 1. What is the derivative of E to the power number times Q? The E will stay as is, and this number will go down. Now, if we just try to simplify this one, we will get 100 E, and then we will have minus Q E 0.1 Q. If we take E as common factor here, that's what we will get as the final derivative. Now, what we need how to find the critical numbers? To find the critical numbers, we need to find r prime of x equal to 0. So you get 100 minus q times e equal to 0. Now we have two brackets equal to 0. So we have to make each one of them equal to 0. So this question can be goes into two parts. I'll solve it little by little. So you get 100 minus q equal to 0. That means if you take q to the other side, we get this one. Next option, you have the e equal to 0. What you need to do next, you need to put ln here and ln here. But once you put ln here, this will give you in the calculator an error. We don't have ln 0. So this has no solution. This branch has no solution. This part will not give you a solution. So the only solution is q equal 100. And this is the critical number. Now, how do we know if this is maximum or minimum? It's a big question mark, right? In order to know if it is maximum or minimum, what we are going to do is very simple. We will apply the second derivative test. So the next step is we apply the second derivative test. In order to find the second derivative test, we need to find r double prime. Let me remind you what is r. It was 100 minus q times e 0.01 q. Now, in order to find r double prime of x, you need to use the product rule again. We have a function here, another function here. So it will be derivative of first times the second plus first times the derivative of the second. Now, what is the derivative of first with respect to q? It will be just -1. What is the derivative of the second with respect to q? It will be this one. And that's it. That's what we get. Do we need to simplify this one? The answer is no. No. We don't need to simplify it. Why? Because all what I need from this one is that I substitute the critical number I found, which it was 100. So all what you need to do, take your calculator, write 100, and see what you get. The answer will be just, without finding the exact answer, or the answer will be just minus e minus 1, which is definitely less than 0. Hence, r of x has a local maximum at, and now let me just write it down as a table. Would be, maybe it would be just nicer for us. Q, P, and then R. This is the maximizer price. And that's exactly what we need to find. And this will be the maximum revenue. And this will be the maximizer quantity. So we have 100 for Q. Now for the price is we just have to multiply to find it here. If we put just 100, it will be 100 e to the minus 1, whatever this number is. We can find it, of course, using the calculator. And then remember, the revenue is the quantity times the price. So it will be, of course, this will be in dollars. This will be number of units. So this will be just 100 $10,000. It will be $10,000 times E. Now, if we just find it using the calculator, this will be approximately 36.79. Sorry. And this would be approximately 3,678.8 dollars. That's the maximum revenue. In example number 3, we are given that the total cost for producing Q unit of a product is given by this formula. And the question is, we need to find the level of a production. Remember, when we are asked to find the level of a production, this means we need to find Q that do what? That minimize the cost. So now we don't need the maximum, we need the minimum. So again, the first step first, we need to find the critical numbers. Now, what's the critical numbers? We need to find the derivative, and we make the derivative equal to 0. Now, what's the derivative for this function? It will be 3q squared negative 48q plus 250 equal to 0. Now, of course, we can use the quadratic formula to solve this question, or in your calculator, do mod 5(3). What you will find, what you will end up, that there are no real solution. The answer you will get if you use the quadratic formula is negative inside the square root, which will give you a complex number. So we don't have a real solution, which means no critical numbers. So no candidate for local minimum. It doesn't mean there is no minimum, but what I'm saying, we will not have the cost will go down and it will go up, which means the cost will go up all the time. It's increasing. That's what it means here. We don't have a local maximum or minimum. It means it will start and will just go up and up and up without going down. But then the minimum is where you will start. Now, where my Q will start, it will start with 0. So, if I just allow here, the minimum actually is gonna be just 0. So, the minimum or the minimizer quantity is Q equal to 0. Why? Because the cost is increasing. And of course, once you have Q, the minimum cost will be when you substitute 0, 0, 0. So the minimum cost will be 3838. But now we just need to find the Q that minimized. We get Q equal to 0. So in the question of the cost, sometimes the minimizer will be the starting point, which will be Q equal to 0. Let's go to example number 4. In example number 4, the weekly revenue of a certain film. So imagine you have a film in the cinema. Now, every week we're generating revenue, and the revenue is given by this model. So we model the revenue by this function. And we need to find the critical values. We need to find how many weeks the revenue increases. So we need to find where the derivative is positive. and what is the maximum revenue. So the first step, we find the critical numbers. Now, in order to find the critical numbers, we need to find the derivative. So what is the derivative? What is r prime of t equal to? Now, in order to find the derivative, I need to use the quotient rule because I have numerator and I have denominator. Now, just let me remind you of the quotient rule. If you look at this one here, this is the quotient rule. So we need to write denominator square, denominator times derivative of the numerator, minus numerator times derivative of denominator. And that's all what we need to do. So I need just to write denominator square, t square plus 36 square. And then you write it again here, times the derivative of the numerator. What's the derivative of the numerator? It's just 50. Minus, and this is very important, don't mess it up, it's minus the numerator, which is 50t, times the derivative of the denominator, which is just 2t. Now, of course, this one I can a little bit simplify it. Take the 50 inside. So what you will get is 50t squared plus, here in the denominator, of course, it will stay as is. We will not change it. Square. Now, if we multiply 50 by 36, it's 1,800. And then we have this minus. And if we multiply 50t by 2t, this will give me just 100t square. Which, if we simplify it even further, this will give me 1,800 minus 50t squared divided by t squared plus 36 squared. And that's what we need to find the critical numbers. Now, let me write it down again here. So what we found is r prime of t is equal to 1,800 minus 50t squared divided by t squared plus 36 squared. Now, for the critical number, we have two options. Either the critical number is equal to 0, or the derivative does not exist. We have to investigate both directions. The reason why, because I have a numerator, so the derivative equal to 0 means the numerator equal to 0, and that means 1,800 minus 50 t squared equal to 0. Of course, this we can solve it by mod 5, 3, and the answer will be 6 and negative 6. Before I continue any further, this is rejected or disregarded. The reason why, because t is the number of weeks. I cannot accept that the number of weeks to be negative. So it should be always non-negative. I cannot expect to get revenue before even I start showing the movie in the cinema. So the only answer from this branch is t equal to 6. I don't know if this will give me the maximum or it could give me the minimum. We will check in a minute, but that's what we get. Now, what does it mean that derivative does not exist? Of course, it means where do we have a problem, and we have a problem if the denominator is equal to 0. Now, the denominator is this one. And that's equal to 0. So we have t squared plus 36 equal to which means t squared plus 36 equal to 0, and this has no real solution. So there is no solution out of this one. Try it with mod 5.3, it has no real solution. So you have only two options, and one of them, they will not give me any solution. The other option give me two solutions, but one of them is rejected. This has no solution. So I will take only t equal to 6. Now, if we look at the question, it's tell me find the critical values, and we did that, and the critical value is t equal to 6. The next question is how many weeks the revenue increases, and in order to do the increases, we need to write the number line. So just let me again take this one here with me to the next page and write it down here. And now the number line is this one. So you have t equal to 6 is here, and I want you to write for me the sign of course, this number must start from 0. So just keep in mind, because t will start from 0. So this is not actually an arrow. This starts from 0. Now, pick a test number here and pick a test number here, and we will check what is the sign of r prime. So the best number I will choose is number 1. So substitute 1, substitute 1. Here you will get always positive. Positive, 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 which means my function will be increasing from week 0 to week 6. Every week I will get more and more revenue. Now pick a number which is a little bit greater than 6, let's say 7. Now substitute 7, you will get all the way negative, which means the revenue will start to decrease. It doesn't mean that we will lose money. It means only that people are not interested anymore in this movie. Maybe there is another movie that is being shown in the cinema and people are starting to go to the other one, and that's what we have. So what do we get? We get local maximum at week 6. So we have the increasing will be from week 0 to week 6, and the local maximum is at week 6. Now the last question is, what is the maximum revenue? So all what we need to do is we substitute 6 and we substitute 6 here to get the maximum revenue. So the maximum revenue will be just the maximum revenue will be just r of 6. So all what we need to do is we need to substitute 6. It will be 72 in the denominator, and if we put 6 here, we will get 300. And that's almost would be 4.166 dollars. Of course, it should be in $1 million. So just let me write it down. $1 million. So this is not an easy. For example, number 4, we are giving the weekly revenue as a rational function, polynomial over polynomial. And of course here t is the number of weeks. So it must be always positive, and this is for a certain film. So this is the revenue of a film in the cinema. Every week the revenue will start to decrease, because at the first week everybody wants to watch the movie. They will go to the cinema, but after like 10 weeks, nobody is more interested. So the revenue will start to decrease. And this is the model that we model the revenue. What we need to do, we need to find the critical values. we need to know how many weeks where the revenue will increases, and we need to find the maximum revenue. Which week will give me the maximum revenue, and then we will start seeing a changing in the behavior. So in order to find the critical numbers, what we need to do, first step, we need to find the derivative. And this is derivative in terms of t. So what is the derivative of this one here? We need to use the quotient rule. So denominator square, that's denominator square, denominator times the derivative of the numerator, which is just 50. And then there is a minus, don't forget this minus, the numerator, which is 50t, times the derivative of the denominator, which is 2t. And here we have t squared plus 36 squared. And now, if we take 50 inside, this would be 50 t squared plus, and then we have to multiply 50 by 36, which is 1,800 minus 100t. And that's the derivative. Now, in order to find the critical numbers, remember, either we write r prime equal to 0, so we take the numerator and we make it equal to 0, or r prime does not exist, which means the denominator equal to 0. So we have two options. We have to keep them in mind. Now, let me just take this one with me to the next page. And now, as I said, we have those two options. R prime of t equal to 0, which means the numerator equal to 0. So we have 50t squared minus 100t plus this one equal to 0. And then we have to solve it using the formula for the quadratic equation, or mod 5, 3. That's how we will need to solve it. And then we have r of t does not exist, which means the denominator equal to 0. Now, what is in the denominator? It was t squared plus 36 squared equal to 0, which means t squared plus 36 equal to 0, and this has no real solution. Okay, in example number 5, we have a manufacturer that produces water tanks that they sell for $400 each. So here the price is already fixed. For each tank, it's been sold by 400. Now, there is a cost in producing Q tanks, and it's given by this formula here. The question is, what is the number of tanks that should be made to maximize the profit? So we are focusing now at this point at the profit. We remember that the profit is equal the revenue we get minus the cost. Of course, the cost is very easy. It's given to us. Minus 20.6 Q plus 5080. However, the revenue, and we remember the revenue is just Q times the price. So Q is Q. The price we know from the question is 400. Now, if we simplify this one, we will start with 0.12Q squared plus 429.69Q plus 5080. And that's the profit function P. So the first question, I found what's the profit function. Next question, I need to find the critical numbers because they will be either maximizer or will be the minimizer. Let me just take this one, copy to the next page, and we'll solve it there. So this is the profit function. First step, we need to find the critical numbers. Remember, the critical numbers, it means the derivative should be equal to 0, and the derivative in this case is given by this formula here. Now, this one, we have to make it equal to 0. So we have P prime equal to 0. It means 0.24Q plus 429.69 equal to 0. That means if we solve, this is a linear equation, take this number to the other side and divide everything by 2/4. So it will be just, if we take this, it will be 1,790 units. Of course, this is approximation because the units must be an integer. Now, this is the answer that we have here. And now we need to check if this answer is local maximum or local minimum. So apply the second derivative test. Now, in order to apply the second derivative test, we need to know what is P double prime. And if you do the second derivative, it will be just this one. So if we substitute my critical number, which is this one, the answer will be fixed to be negative 0.24, which is always less than 0. Hence, P, which is the profit, has a local maximum. And this is exactly what I'm looking for. I'm looking for a local maximum at Q equal 1079. And that's the answer here. So it says, what is the number of tanks that should be made to maximize the profit? How many tanks? It should be given by this number here. So sometimes we need to find the revenue and we need to subtract the cost out of it. Let's look at this equation. In this equation, we have a demand function for a product. So I have the price. I have the average cost, C prime. And remember, C prime is just C divided by Q. It's given to me. And now find the selling price that maximizes the profit and find the maximum profit. So in this equation, again, we need to do the same thing as we just did by writing that the profit equal revenue minus cost. However, I don't have the cost and I don't have the revenue directly. So let me just try to find them from the question. First of all, let me find the cost. I don't have the cost, but I have C bar. Now, what is C bar? C bar is just C divided by Q. And remember, I want only C, so C would be Q C bar. So we take this one and we multiply it by Q. So this would be Q squared, Q, and 1000. So here we have Q squared plus 100Q plus 1000. And that's just the cost, which is C. How about the revenue? Well, actually the revenue, which is R, it would be Q times the price. This is a Q. What is the price? The price again is given to me in the question. It is 700 minus 2Q. So the final answer would be 700Q minus 2Q squared. I have the cost, I have the price. I can now go ahead and write the profit function, which I will find the derivative in a minute. So again, what is the profit? Equal to, remember, it is the revenue minus the cost. Now for the revenue, we find it as 700Q minus 2Q squared minus the cost was given by this formula here, plus 1,000. So if we simplify this one, it would be 700Q minus 2Q squared minus Q squared minus 100Q minus 1,000, which all in all, minus 2Q squared minus Q squared, this gives me minus 3Q squared. 700Q minus 100Q, this will give me minus 300Q. And finally, minus 1,000. And this is my profit P. What we need to do next, we need to find the critical numbers. Remember, the critical numbers will be either the maximum or the minimum, and we will check that using the second derivative test. So we need to find the derivative of this function, and we'll make it equal to 0. What is the derivative of minus 3Q squared? It will be minus 6Q minus 300 equal to 0. Now, in order to do that, we need to find Q. And in that case, Q will be just 50 units up here. And now all what we need to do is we need to just go ahead and find. Now let's look at example number 7, where the annual profit for a store in thousands of dollars is given by this formula. So here I have the profit given to me directly, where X is the number of years past 2013. So X is the number of years, not a quantity. If the model is accurate, now suppose this is a model and it's been tested for many years and it's accurate, we need to find the point of diminishing return for the profit. What does it mean, diminishing return? We will see it, but diminishing return for us mathematically, it means we need to find the inflection point. I will find the inflection point, I will substitute it, and then I will explain to you what does it mean for the diminishing return. So in order to find the inflection point, we need to find the derivative, and then the second derivative, and make the second derivative equal to 0. So the first derivative will be just given to me by 0.6 x squared plus 6x. Second derivative, which is the most important here in this application here, it will be negative 1.2x plus 6. Next, we write the second derivative equal to 0, which means negative 1.2x plus 6 equal to 0. And that means x is equal to 6 divided by 1.2, which means x is equal to 5. Of course, this should be years here. So that means we will start to have the function here, we will start to have a concave up. What will happen is that the profit will start to increase before the 5 years, and after the 5 years mark, we will have a different, the price will start to decrease. It will kind of a concave up and concave down. It's like it will go like this, and after 5 years it will start moving to the other direction here. So first it will go concave upward, and then after 5 years it will just, looks like it will start to